Dear students, hope you are all well. I am Nayak. Today, this is the fourth part of this chapter, a pair of linear equations in two variables. Today, I am going to teach you about the geometrical representation and the algebraic interpretation of a pair of linear equations in two variables. This particular concept is extremely important from the examination point of view. It's very easy, just a bit of attention is required. Now, let's start. A general form of a pair of linear equation in two variables is written like this: a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. This is the first equation and this is the second equation. Have a look. As I have told you in the earlier classes that without drawing the graph of these two given equations, we can predict whether these two equations will have a unique solution, infinitely many solutions, or no solutions. In other words, whether the graph will be intersecting, or they will be parallel or coinciding. Without drawing graphs, if you draw the graphs, you can easily get it. But without drawing the graphs, we have to predict by looking at this equation only. At a glance only, we should be able to predict whether the graph will be like this, or like this. If it is like this, it will be a unique solution. This is exactly one solution. This will be infinitely, there will be no solution. Here in this case, there will be infinitely many solutions. To understand this, let us take a simple example. Take a very simple example. It is very easy. Let us write any equation as you desire. Suppose I write 2x plus 3y is equal to 4. This is equation 1. Now, let us consider another equation. How you multiply this whole equation by, suppose, 2, 3, any number you like. For simplicity, let us multiply the LHS and the RHS by 2. If we multiply this equation by 2, we will get what? 2 2 is a 4x, 2 3 is a 6y, and 2 4 is a 8. Now, if you mark this as equation 2, and if you look at these two equations, what type of this equation is? Now see, here we have derived this equation from this equation. How? By multiplying by multiplying the coefficients by 2. Here, if this is a1, b1, c1, a2, b2 and c2, you see a1 by b1. a1 by b1 is equal to 2 by 4. So it is equal to 1 by 2. Similarly here, sorry, a1 by a2. a1 by a2. a1 by a2. Similarly, b1 by b2, b1 by b2 is equal to 3 by 6. Again, it is 1 by 2. And c1 by c2 is equal to 4 by 8 is equal to 1 by 2. So here a1 by a2, b1 by b2 and c1 by c2, all these three ratios are equal. Why they are equal? Because simply we have multiplied the coefficients of this equation with 2 and we got the second equation. So this equation is not at all different from this. These are two equivalent equations only. So the graph of this and the graph of this, in this case you see, if a1 by a2, b1 by b2, c1 by c2 equals, this means this has been derived from this, because this has been multiplied by 2. So here in such type of equation, this is the condition. If you got after doing a1 by a2, b1 by b2 and c1 by c2, from here we can say that the graph here will be just like this. Like this. They will be coincident. Because these two, mathematically, these two equations are exactly same. There is no difference. If you draw the graph of this, suppose if this is the graph, then this will be this. So you are getting the same line only. So here we will have infinitely many solutions. In this case we will have, without drawing, no need to draw the graph. If the condition of a1 by a2, b1 by b2 and c1 by c2, they are equal. So here we are getting what? a1 by a2 is equal to b1 by b2 is equal to c1 by c2. If this is the condition, then we can say the given pair of linear equations will have coincident lines and they will have infinitely many solutions. Infinitely many solutions. This is the first. Now same thing what we will do here, we have again, let us take the same equation. Now 2, here we have multiplied the whole equation by 2. Now in this case what we will do, we will only multiply these two by any number you like, any number. Suppose we multiply these two by 3. So it will be 3 2 is 6 plus 3 3 is 9y is equal to, you don't multiply this one with any number, or you can multiply with any other number, not with 3, because we have multiplied this one by 3 and this one by 3. So 3 2 is 6, 3 is 9. You can multiply this one by 4 or 2 or 1 or make it like that, remain it like that only, keep it like that only. Suppose it is kept it 4 only. So here if you see, this is the, so again I will repeat, in the previous case what we have done, we have multiplied the whole equation by a number, but here we have only multiplied this a1 and b1 with a fixed number to get this equation. Here if you see, this is the a1 by a2, it is equal to 2 by 6, it is equal to 1 by 3, and b1 by b2 is equal to 3 by 9, so it is equal to 1 by 3, and c1 by c2 is equal to 4 by 4 is equal to 1. So what we see here, a1 by a2 is equal to b1 by b2 but not equal to c1 by c2. Why? Because we have not multiplied the same number for which we have multiplied by these two. So in this case, if you plot the graph, you will see that you will get parallel lines like this. Like this you will get. Means you will have no solution in such type of equations. So without drawing the graph, from here only, by observing the value of a1, b1, c1, a2, b2, c2, we can say whether the graph will be parallel or not. If this is the condition, then graphs will be no doubt parallel. So again I will repeat what we have done here. In the previous case, we have multiplied the whole equation with a single number, any number you like. But here we have multiplied a1 and b1 with the same number to get a2, b2, but we have not multiplied c1 with any number. Or we can multiply c1 with some different number, not with that number which we have multiplied with these two. Now the last one, third. Now let us again begin with the same equation. Now here what we will do, now at your own desire, whatever you feel, you write. Suppose you write here, suppose 4x. So here how you have got with multiplying by 2. Here you don't, you have got this one by multiplying with 2, you don't multiply with the same number, you multiply with any other number. Or you keep the same number. Means you can ensure, now you can keep it, suppose 5y is equal to 6. It is 2. Any random number you pick, you put any random number here. You can take any random equation, but ensure that a1 by a2, here what is a1 by a2? 2 by 4. It is equal to 1 by 2. And what is b1 by b2? Is equal to 3 by 5. So a1 by a2 is not equal to b1 by b2. Don't bother about c1 by c2 in this case. Irrespective of what is c1 by c2, you have to only see what is a1 by a2 and b1 by b2. If a1 by a2 is not equal to b1 by b2, in such case, here you see a1 by a2 is not equal to b1 by b2. We are not bothered about 4 by, in any way. In this case, we are not considered c1 by c2. If this is the case, then you are going to get intersecting lines. So dear students, these are the only 3 conditions. So in summary, what we got? First we got a1 by a2 is equal to b1 by b2 is equal to c1 by c2. What we did? You write any equation you like, then multiply the whole equation by any number you like. Any number. In this, the condition will be like this. So here the lines will be, here the condition, what it will have? So it will have coincident. It will be like this. Coincident lines. Coincident lines. Coincident lines. So you will have infinitely many solutions. Infinitely many solutions means what? Many solutions means more than one. It may be 2, 3,000, but infinitely. There is no end to it. Infinitely many solutions. Don't think that 1,000, it may be more than infinite. Infinite solutions in this case. The condition is, dear students, I will again repeat, this is the most important part of the whole chapter, and you are going to get a question without any doubt. So please be careful about this particular part of this whole chapter. This is the condition 1. Condition 2, here what we have seen, in that case we have multiplied a1 and b1 with the same number but not the c1. So what you will get here, a1 by a2 will be equal to b1 by b2 but not equal to c1 by c2. If this is the condition, then you will have parallel lines. Parallel lines like this. Parallel lines. And here we will have no solution. No solution. And 3, A1 by A2 is not equal to B1 by B2. It is the most, this is the most, the questions which you will get will be like this. Here, in this case, no, we are not connected with C1 by C2. In no way. In this, only this condition is sufficient. If A1 by A2 is not equal to B1 by B2, whatever may be C1 by C2. Irrespective of whatever is C1 by C2, if this condition is fulfilled, means A1 by A2 is not equal to B1 by B2, then you are going to get intersecting lines. And here you will have exactly one solution. Exactly one solution. Because this is the intersecting lines. So these are the three things. So I hope this point might have been clear by this time. So now let us make the tree. This is the most important part of the whole chapter. Many tricky questions are going to be asked from here. In exemplar also, there are a lot of questions based on this concept. Now, let us make the tree to clearly understand. Here we'll get the geometrical representation as well as the algebraic interpretation. Now you see, first of all, a pair of linear equation. A pair of linear equations. A pair of linear equations. What? First, what you will get? You will get what? Either has, if a pair of linear equation is given to you, either you will have what? Has solution. Has solution. And the other one has no solution. Either it will, the equation, a pair of equation has a solution, or it will have no solution. If it has a solution, if any pair of given linear equation has a solution, they are called consistent. They are called consistent. Sorry. They are called consistent. In this case, they will be simply called inconsistent. Inconsistent means if a given pair of linear equation has a solution, then it will be called a consistent pair of linear equation. Again, I will repeat. A consistent pair of linear equation is that equation which has got solution, and an inconsistent pair of linear equation is that equation which has got no solution. That's it. Now here it can be bifurcated into two. That is over, has no solution. Okay, gone. But here, if it has solution, now again it will have two types. Either it will have exactly one, exactly one solution, or you can say unique solution, or you can say, or oblique you can say unique solution, exactly one solutions or unique solutions. Here you will get infinitely many solutions. Exactly one solution or unique solution, or infinitely many solutions. That may be two. So if a pair of given linear equation has solution, then two cases arise. Whether it has got one solution or in many solutions. If it has got exactly one solution, they are called independent equations. Independent equations. And if they have infinitely many solutions, they are called dependent equations. Consistent equations. Inconsistent equations. Independent equation and dependent equation. So we can say, what is an independent pair of linear equation? A pair of linear equations will be called as independent equations if it has got exactly one solution. Similarly, how a pair of independent equations can be defined? A pair of dependent equations, a pair of dependent equation is that pair which has got infinitely many solutions. So this is the stratification of a pair of linear equations. Now we will get the geometrical interpretation. The geometrical interpretation, you can say the geometrical representation. I am writing in short, geometrical representation. Here independent equation means what? Exactly one solutions. The intersecting lines, you will get intersecting lines like this. Intersecting lines. This is the geometrical interpretation. And here the geometrical interpretation will be geometrical representation. It will be dependent equation, infinitely many solutions. They will be coincident lines. They will be coincident, intersecting lines, coincident lines. Coincident lines. Now don't worry about the definitions, it will be at the end of the video. Now here the geometrical interpretation will be, the geometrical representation here has no solutions, so it will have parallel lines. Parallel lines like this. Now we will go to the algebraic interpretation. I am writing in short. Though it is not the recommended abbreviation, just there is no space, so I am writing it is algebraic interpretation. It is given in the NCERT book, and this is the geometrical representation. The geometrical representation will be intersecting lines like this, and algebraic interpretation is very important. Here you will get A1 by A2 will not equal to B1 by B2. A1 by A2 will not be equal to B1 by B2. In this case, the algebraic interpretation in this case will be A1 by A2 will be equal to B1 by B2 will be equal to C1 by C2. And here the algebraic interpretation, here it will be parallel. It will be like this, has no solutions, parallel lines. So it will be A1 by A2 will be equal to B1 by B2 but not equal to C1 by C2. Dear students, this is very, very important. Try to think deeply It is not too difficult. Just a little bit of thinking, you can get to it. So this is the stratification or the divisions of pair of linear equations. So here I will summarize a pair of linear equation. So either a pair of linear equation will have solution or it will have no solution. So if it has solutions, then the arises the two things, whether it will have one solution or it will have infinitely many solutions. So if it is exactly one solutions, they are called independent equations, and if they have infinitely many solutions, they are called dependent equations. So the geometrical representation, intersecting lines, exactly one solution, because this point of intersection will be the solutions to this type of equations, independent equations. Independently many solutions. Here if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then we will have infinitely many solutions. And if a1 by a2 is equal to b1 by b2 not equal to c1 by c2, then it will have no solutions. Here it is extremely important. So you see, as I have told you earlier, without plotting the graph of a given pair of linear equations, we can, with a little bit of maths, I have told you, we can predict or we can find out whether it will have a solution or it will have no solution. If it has solution, whether it will have exactly one solution or many solutions. Now these are the conditions. If two equations are given, just you have to see this. You do this. If it comes like this, then you have to exactly one. And this is simply a bit of practice is required. Don't memorize. If you memorize, you will soon forget. Okay, it will soon evaporate from your brain. But if you think it, intersecting lines, coincident lines and parallel lines. Here you will have one, here you will have many, and there will be no solutions. So like this way also you can get solution, no solution. If solution, one solution, or infinitely many solutions. So that's it in this today's class. So I hope you have understood it very well. In the last session of this chapter, we will do several questions on this from NCERT, from R.D. Sharma, and also from Exemplar. Lot of questions we will try to do it. So till then, dear students, thank you. So as usual, please subscribe if you like this video. So it is simple, it is free also, and it's very simple. Just you have to subscribe and hit the bell icon. So till then, enjoy. Thank you.